There's a world out there where the wind screams at you faster than the speed of sound, where storms the size of Earth rage for centuries, where the sky glows an unnatural blue that no human eye has ever seen in person. And we've only visited it once, for less than 5 hours. Neptune isn't just far away, it's actively hostile to understanding, and the deeper we look, the less sense it makes. If you're fascinated by the edges of what we know and what still hides in the dark, you're in the right place. Hit subscribe because we're diving into mysteries most people will never hear about. Imagine standing on a frozen beach at the edge of our solar system, 30 times farther from the Sun than Earth. The Sun itself looks like nothing more than a bright star now, offering almost no warmth, no comfort. You're standing on the 8th planet, and everything here wants to kill you. The atmosphere is crushing, the cold is absolute, the winds would tear apart anything we've ever built. But here's the strangest part. Neptune shouldn't even exist. When scientists first calculated how planets form, Neptune broke the rules. Out here, so far from the Sun, there wasn't enough material, enough energy, enough time for a giant ice world to pull itself together. The math said no, but Neptune said yes anyway. It formed somewhere else, closer to the Sun, in a cosmic neighborhood that made sense. Then something happened, something violent. Neptune got kicked, flung outward by gravitational chaos during the solar system's wild teenage years. It drifted to the frozen edge and stayed there, orbiting in exile. That's the first mystery, but it gets weirder. Neptune radiates more heat than it receives. Let that sink in. This planet, billions of miles from any meaningful sunlight, is warmer than it should be. It's glowing from the inside. Scientists think it might be leftover heat from its formation, still leaking out after 4.5 billion years. Or maybe something else is happening in that crushing interior, something we don't fully understand yet. Diamond rain, perhaps? Under the immense pressure deep inside Neptune, carbon atoms might crystallize and fall like hailstones made of gemstones, sinking through layers of superheated ice until they reach the core. We think this happens. We can't prove it. We've never seen it. We just know the physics suggests it's possible, and that alone should make your brain hurt. Now let's talk about the storms. In 1989, Voyager 2 flew past Neptune and sent back images that stunned everyone. There, swirling in the southern hemisphere, was a storm system so massive it could swallow Earth whole. Scientists called it the Great Dark Spot. It looked like Jupiter's Great Red Spot, but darker, angrier, spinning backward. They expected it to be permanent, a feature that would define Neptune for generations. But when the Hubble Space Telescope looked again a few years later, the Great Dark Spot was gone. Vanished. No explanation, no warning. In its place, new storms had appeared in completely different locations. Neptune's atmosphere isn't stable. It's chaotic, unpredictable, constantly reshaping itself in ways we still can't model or forecast. And then there are the winds. Neptune holds the record for the fastest winds ever measured in our solar system. Gusts reach 1,200 miles per hour. That's nearly twice the speed of sound on Earth. To put that in perspective, the fastest jet fighters we've built top out around 1,500 miles per hour, and they need engines burning thousands of pounds of fuel. Neptune's winds do this naturally, continuously, powered by some internal engine we barely comprehend. Remember, this planet receives almost no energy from the Sun. So where is all this power coming from? The interior heat helps, but it still doesn't fully explain the violence, the speed, the relentless fury of Neptune's atmosphere. Here's where it gets personal. We know almost nothing about Neptune compared to other planets. Mars has been visited by dozens of spacecraft. Saturn has been orbited and studied for years. But Neptune? One flyby, one spacecraft, 5 hours of close observation in 1989, and then Voyager 2 kept going, disappearing into interstellar space. Everything we know about Neptune comes from that single encounter and whatever we can glimpse through telescopes from billions of miles away. We've spent more time studying some asteroids than we have studying the 8th planet. Let's talk about Triton for a moment, because Neptune's largest moon might be even stranger than the planet itself. Triton orbits backward. Every other major moon in the solar system orbits in the same direction its planet rotates. Not Triton. It goes the opposite way, which means it wasn't born here. Neptune captured it, ripped it away from its own orbit somewhere else in the outer solar system, and locked it into a death spiral. Triton is falling. Slowly, over millions of years, it's getting closer to Neptune. One day, in the distant future, it will cross the Roche limit, the point where Neptune's gravity becomes too strong. Triton will shatter, torn apart into a ring system that might rival Saturn's. But that's millions of years away. For now, Triton survives, a frozen captive with geysers that shoot nitrogen ice into space. A moon that shouldn't be where it is, doing things we never expected. What haunts scientists most is what we're missing. Neptune's magnetic field is tilted at a wild 47-degree angle from its rotation axis and doesn't even pass through the planet's center. It's offset, asymmetric, completely bizarre. This suggests something deeply strange about Neptune's interior structure, but we can only guess. We've never sent a probe into its atmosphere, never measured its depths, never truly understood what's happening beneath those blue clouds. For all we know, there could be entire layers of exotic chemistry down there, states of matter that don't exist anywhere else, phenomena that would rewrite textbooks if we could just get close enough to see. And here's the question that should keep you up at night. If Neptune is this mysterious, after billions of years of existence in our own solar system, what does that say about ice giants orbiting other stars? Neptune-like planets are probably the most common type of world in the galaxy. When we find exoplanets around distant stars, many of them are Neptune-sized ice giants. We're discovering them by the thousands, but we don't understand the one in our own backyard. We're trying to characterize alien worlds light years away when we can't even explain the storms on Neptune. I want you to think about something. Right now, as you're watching this, Neptune is out there, spinning in the darkness, generating heat, spawning and destroying massive storms, holding on to secrets we can't reach. No human has ever seen it up close. No human probably will in our lifetimes. It exists at the edge of our awareness, a reminder that even in our own neighborhood, mysteries remain. We mapped Earth. We've sent people to the moon. We've landed robots on Mars. But Neptune? Neptune stays unknown. What do you think we'd find if we sent another mission to Neptune tomorrow? What's your theory about those impossible winds or that internal heat source? Drop your thoughts in the comments, because honestly, some of the best ideas come from people willing to imagine what scientists haven't considered yet. If this made you see Neptune differently, if it made you realize how much we still don't know about our own solar system, share this with someone who needs that same sense of cosmic mystery. The universe is bigger and stranger than most people think about in their daily lives, and sometimes we all need that reminder. Neptune will keep spinning out there, 4.5 billion miles away, glowing its impossible blue, screaming its supersonic winds into the void. And maybe one day we'll go back. Maybe one day we'll finally understand. But until then, it remains what it's always been. A beautiful, hostile, deeply mysterious world at the frozen edge of everything we know, whispering questions we're not yet ready to answer.